he just skips over everything. I can't believe that guy. Don't worry. Yeah. Actually, the number 5 is a sign, but I'm going to just talk about that one to get you started, so we can talk about it in the class. So again, if you have your book, I'll write it out on the. I'm not going to write it word for word. I'm going to give you paraphrase it. Okay, so here's a little, this has nothing to do with math. This is just a middle of the class. Don't use smartphone. So I think I told you guys that my family is from England, and I am a British citizen. I moved here when I was 5, hence no accent. But so I listen to this radio. You can stream. It's great nowadays. You can stream radio stations. And I listen to this radio station that's from the area of my schools in an athletic conference compete in a cross-country meet to which each school sends 3 participants. Aaron, Caitlin, and Ileana are the 3 representatives from one school. So then they tell you information about where they finish. It says Aaron finishes the race in the middle position. So let's write that down. So Aaron with an E. Caitlin finishes after Aaron. Caitlin with a K. So this is number 5. And Ileana, one in, finishes 28th. How many schools took part in the race? Okay. So, the question, so it's, there's no formula for this. So how do you approach this? Yeah, well so where is the middle? Yes. So you have as many runners less than you as greater than you. So how many, are the number of racers going to be odd or even? Based on that statement. If Aaron, Caitlin, or Aaron is in the middle. So if she's the middle, and they're an even number on one side, and an even number on the, well, they don't have to be even, but they have to be, the total has to be even outside of that. So that means there are odd number of racers, right? Because they can't, if there were an even number of races, you'd have 2 people in the middle and not 1 person in the middle. Okay, let me just, nobody's going like, yeah, that's interesting. They're like, what? That's why I said, these are not easy. So let's say you have 6 racers. So you'd have 1, 2, 3, 4, 5, 6. If you have 5 racers, then you'd have 1, 2, 3, 4, 5. So the middle of the racers would be here. So if you had, you'd have to say either 2 people are in the middle or none are in the middle. Whereas with 5 races, you have a middle. So that means that the number of racers has to be odd. Okay, now, what else can you say about the total number of racers that are running in this race? Are they a multiple of any number? There are 3 runners per team. So the number of racers has to be a multiple of 3. Okay, so let's just kind of write this down as what we guess what they could. Whoop. So you could have 3, you could have 6, you could have 9, you could have 12, 15, 18, 21, 24, 27, 30, 33, 36. The answer is less than 40. So, well, they can't be these ones because then there'd be no middle. So they have to be those, right? So those are my choices, 6, 9, 15, 21, 27, 33, 39, because they have to be multiples of 3, and they have to be odd. So we've reduced it down from 40 people down to 1, 2, 3, 4, 5, 6, 7. There's 7 options. So let me delete this page. So now, so Ileana finishes 28th. So there have to at least be 28 people, right? She can't, if there's only 26 runners, you can't finish 28th. So that gets rid, that particular piece of information is used for getting rid of this one, this one, this one, this one, and that one. So trying to think about that. So let's see, Ileana is in 28th place. If oh, 19th position. Okay. So that's Caitlin is here, and it's the, oh, she finishes after, oh, she actually, they give her position. Okay, I was thinking there was something missing there that would help us. Okay, Caitlin finishes after Aaron in 19th place. Okay, that's one additional place, because otherwise you could probably keep going on higher multiples. But so our 2 choices here are 33 and 39. So let's think about that. Does 33 work? So yes, if you have Caitlin, the middle position would be number 17, I think. 17, because you have 16, then 17, then you have another 16 afterwards, which would be 33. So in that case, there's enough people, so the middle position places Aaron in the middle with Caitlin after Aaron in 19th place. And then you have, in the next position is Ileana, which is 28. Now why 39 might not work? Well, the reason 39 wouldn't work because the middle position there would be 19, which is the same place that Caitlin gets, and so that eliminates 39. Okay, so that's why 33 works and all the other ones don't. So let's review what we did here. We said because each school has 3 runners, the number of runners has to be, so there's 33 people, which means 11 teams. Okay, that's the answer is 11. There are 11 teams. So the fact that there are 3 participants per school, the number of participants has to be multiples of 3. Then, because the middle position only happens when you have an odd number of runners. We can eliminate all the even choices, 6, 12, 18, 24, 30, and 36. Then we know that there are at least 28 runners, so we know that we can get rid of everything less than 28 outright. So that left us with 33 and 39. 33 works. 39 doesn't work because then we'd have Caitlin and Aaron at the same position, which is not what happens. She finishes after. So it's it's kind of a roundabout way of doing it. I'm writing down numbers here. I'm not trying to remember things all in my head. I'm trying to eliminate stuff to come to a final solution. So anyway, there's your whole. I did it for you. So now you can read it and do it again when you do it the other day. That was one I got. Some of them I didn't get. I don't think I assigned any of those to you. So if I couldn't do it, then I wasn't going to ask you to do it. What time is it here? 1:50 something. Has anybody ever done any genealogy? What's that? Genealogy? Yeah. You kind of do the same thing with the genealogy sometimes if you're tracing your ancestors back. Because has anybody ever watched those things on TV, the genealogy shows like Who Do You Think You Are or what's a Genealogy Roadshow, whatever, and you see those. And because my family's from England, in some ways it's easier because back there was laws that required people to be, all marriages and births to be met, or christenings to be recorded by the churches, even before the civil requirements where there were church requirements. And so you can go back and you can look that stuff up. But the figuring out who the father and the mother are of a child, you do things like you look at census records, and census records tell you the person's name, where they were born, and how old they are. So what you do is you take that information, subtract how old they are from the date the census was taken, then you have the birth date, and then you have the birth location. So then you go into different records and you say, you search for people named this who were born here this date, and you may get, and it's amazing how you eliminate a lot of, it doesn't take too many things to eliminate people who are not your relatives. So you can actually go back pretty far as long as there are records, but it's the same kind of puzzle. Maybe that's why I like it to some extent. Yep, go ahead. Gauss theory, yeah. Okay, sure. Yeah, so the idea was if you add the numbers from 1 to up to some number, what is the sum of those numbers, doing it quickly instead of doing it a long way. So I'm going to pick a smaller number here. Let's say I want to add the numbers from 1 to 50. What's the answer? So the idea is you recognize that if I take the first and the last and the second and the next to last and so forth and so on, all of these you can just add the first and the last together and you get 51. And so this pair equals 51. And this pair equals 51. And so because there are 50 numbers, there are 50 divided by 2 pairs that add to 51. So the answer is going to be 50 divided by 2, which is 25, times the sum of the pairs, and then you just multiply those two numbers together. So you get 25 times 51 is 1,275. So when you see something like this, basically you just add the first and last number, multiply it by the last number divided by 2, and it just saves you a lot of time. So that's how that works. That's Gauss's, I don't know if it's called Gauss's theorem or just Gauss. We'll just say it's Gauss's thingy-diggy. No. Gauss's method. Just using inductive reasoning, because you're observing that the first and last add to the same number as the second and next to last, and then you can come up with a rule. The rule is that. And that number is not 57. It kind of looks like that, but it's 51. Yep. Yeah, genealogy in England is interesting compared to America. America for hundreds of years was more of an agrarian society. Farmers had more farmers, and then the Industrial Revolution came, and there were people that worked in the factories and things like that. In England, it's much different because the people who owned the land were not the farmers. So when you had too many farmers, then they sent them to the cities, and they did interest jobs more so different than what if you look in America. So my family comes not from royalty. I'm not, I always find somebody, oh, I'm related to king whatever. Well, I have no relatives that are kings. I had a coal miner, a servant in a household. Does anybody watch Downton Abbey? You got any Downton Abbey people in here? Anyway, if you like Harry Potter, you should watch Downton Abbey. Anyway, it's about a upper class family with the servants working for them. So